Well, now let's take a look at really the last main idea that we're going to cover in section 2.1, which is shapes of distributions. We've seen that we can actually create with quantitative data these kind of histogram or bar graphish like sort of shapes where these bars touch. But we also saw that actually even when we looked at things like stem and leaf plots or dot plots, we had the same kind of bar-like structure. And so we can imagine kind of looking at how our data is organized, and those bars might fall into some different sorts of shapes. Now we're going to focus here on four shapes. These are not the only four shapes you could ever have when you draw bars, but these are very common shapes. You'll see the first one is what we call bell-shaped or symmetrical. And of course that makes sense because you can almost kind of imagine dividing this picture right down the middle. And you can also see that if I was to kind of trace over it loosely, it kind of has the shape of like a bell. Okay, we also have a uniform shape, which makes sense because when I think of things in uniform, they all look the same. And here, all my bars pretty much have the same height. I see that when I talk about skewed left and skewed right, it's almost symmetrical, but it's almost like this big stack or pillar in the middle has been pushed over to a specific side. We'll be able to distinguish skewed left and skewed right by where this tail of the distribution is, where this kind of leftover stuff is. If the leftover stuff is on the left, skewed left. And if the leftover stuff is on the right, it's skewed right. Okay. Now what's really important here, what is so crucial is this note at the bottom. Not all data is going to exhibit behavior, when put into a picture, that matches perfectly one of these shapes that is given. In fact, it is very unlikely that you will come across things where all your bars are always the same height, or that you're going to have a perfectly symmetrical shaped distribution. It's not going to be the case. So, some flexibility and subjectivity is going to be required when identifying the shape of a distribution. Let's take a look down here at example 4 to see how we're going to do this. I want to go back and take a look at the previous quantitative distributions. And I'm going to try to label each of them with one of the common distribution shapes that we have up here. So let's go back and take a look at the Initech data for example 3. We have these bar graphs. Or, sorry, I should say we have these histograms. When I look at these histograms, we can see a rough idea of what the shape might be. Can you maybe take a guess as to which of those four shapes down below seems to fit here? Well, I would probably say maybe this is kind of skewed to the right. I can kind of see I have like a big mound of data over here, and then it kind of tails off over on the other side. So maybe this is something that's kind of skewed to the right. It doesn't look as skewed right as this, but that's okay. This is where flexibility and subjectivity comes into this. So I could say my Initech data is, we'll say, skewed right. Well, what about the Wendy's data? That is the one that came from that dot plot. Well, if I take a look at this, can you think of a shape that seems to fit it? Well, you could probably get away with a couple things here. I mean, I would probably say that maybe something like symmetrical seems pretty good because notice, actually, if this dot was right here, this would have been perfectly symmetrical. But I could also see that if you almost kind of can ignore this, it almost looks like it's kind of skewed towards the left side, right? Okay. So again, some subjectivity is going to be involved here. I'm going to go ahead and say that this is probably closer to being symmetrical than anything else, and so I'll write that down here. This is symmetrical. What about the stem and leaf plot? That was the price data that we had. Well, notice if I kind of tilt my head a little bit, I can see that these bars kind of start high on the right side and tail off onto the left. And so this seems like a good candidate to be skewed to the left. Now again, when it comes to exams or other assessments in this class, I'm always going to try to make it unbelievably clear as to which of these you should select. I'm never going to try to give you something that's in a gray area. I'm going to make it really, really easy to identify which of these four shapes you might have. Again, keep in mind these aren't the only four shapes, but they are some of the different possible shapes that we could have. And we'll see how all of this information can kind of be summarized again in example number 5 that we'll cover in the next video, where we'll do another simulation.